Okay, here's the solutions for the mock for advanced functions. Number 1, the weight of a dog W varies directly with the cube of its shoulder height H. A dog that stands 20 inches tall at the shoulder should weigh 30 pounds. Okay, so it says to write a function W of H connecting W and H. So remember that this notation WH corresponds to the function notation f of x. So remember that f corresponds to y and x corresponds to the input variable x. So if I say that h is in the parentheses, that means h corresponds to x, and if I say that w is outside the parentheses, it corresponds to y. Okay, so basically I'm going to have a function w equals, or w is varies directly with the cube of h. Okay, and now I'm going to write that into equation, so I'm going to write w equals k times h cubed. Now, what information have they given me? They said that a 20-inch tall dog weighs 30. So I'm going to say, to find what k is, I'm going to put in 30 for w, and I'm going to put 20 in for h. And then I'm going to solve for k. So I'm going to divide both sides by 20 cubed. So 30 divided by 20 cubed equals k. So now I'm going to do that on the calculator. So I'm going to put 30 divided by 20 cubed. And the answer is 0.00375. So the function I'm going to write is w of h equals, and I'm going to put kh cubed, except my k value I already know is 0.00375. So it's w of h equals 0.00375 times h cubed. So all I did was I took this function and I substituted in my known value of k, and that gives me a function which connects w and h. Given that a dog has a height of 12 inches, what would be its height? Okay, so this, remember, is the input, so all I need to do is put 12 in for h. So I could put W12, for example, and then I put my k value, which is 0.0, it's always going to be 0.00375, and I'm going to multiply it times h cubed, so that would be 12 cubed. Okay. So now what I'm going to do is I'm going to, since I'm probably going to answer more questions using this function, I'm going to put this function into y1. 12 cubed, I'm just going to put x cubed, and then I'm going to use the table to figure out what the value is at x equals 12 or h equals 12. So there it is. The value is going to be 6.48. Another way to do that is to graph it and then do trace 12. Oops, I went off the screen. It didn't like that. So let me do window, and I'm going to change the x max to 12. I'm going to regraph it. And then now I'm going to do trace 12. Trace 12. And it gives me the y value of 6.48, or the w of 6.48. Find the height of a dog that weighs exactly 15 pounds. Now they're giving us the w value, which is the output. So let's try to do that with the table. Now we try to find a y value that's 15. I'm not sure if we're going to be able to do that because we don't have every single y value on the right side, right? Looks like 16 is pretty close. What if I wanted to see where exactly it is between 15 and 16? First thing I'm going to do is I'm going to do plus 0.1. Looks like 15.9 is probably going to be, 15.9 is probably going to be the answer. Okay. If I wanted to get one more digit, I could do plus 0.01. Looks like 15.88 is even closer. So if we wanted one more digit, we could write 15.88. Okay. Not sure if it's 15.87 or 15.88. Let me think. No, 15.87 is actually closer. Okay. Now I'm going to show you what I think is a better way to do it. You go into y equals. For y2, you're going to put your desired y value, or your desired w. You're going to put 15 here. Okay. And then you're going to see where the intersection is. Unfortunately here, my graph is not including 15 here because my window size is a little bit too small. So I'm going to change my y max to about 18, and that'll make sure that y equals 15, which is a horizontal line at 15, is included. Okay, I guess we need to go a little bit farther to the right. So we'll go to like 25 or so on x max. Okay, and there's our intersection. So then we do second calc, intersect number 5, and then we hit enter a couple times to do first curve, second curve select, and then we hit enter for guess, and our intersection is 15.87, just like we found on the table, right? Okay. Graph the function w of h with w on the y-axis and h on the x-axis. Graph for the domain. X is between 0 and 30, and the range is between 0 and 30. Okay, so I'm going to use the table to get values for that. Oh, let me change back to the regular table. So I'm going to do second table set, 0 for table start, and table delta table I'm going to put 1, and then I'm going to go back to the table. And then I'm going to go to the grid paper, which is in a couple pages, and then I'm going to graph from x equals 0 to 30. Okay, so we'll start the graph here and here. So we'll go 30, x equals 0 to 30 and y equals 0 to 30. Let's just graph every few point, not like every single point, like 0, 0, of course. Let's count by 5. So 5, 0.468. Okay. I can count by 5s actually. Let's do that. So we'll do plus 5. So 10, 3.75. 15, 13. Oops. 20, 30. 20, 30. And I am already off the screen, so I can stop there. So this is my function. Okay, and I'm just going to label my axes. So this is W, or H, and W for my function. And I'm going to label the axes. Okay. All right. we've graphed it. Now let's go back up, finish up the problem. So we graphed it. Graph the inverse function w to the -1 of h on the same axes. Okay, so remember, when you graph an inverse function, what you do is you take all the points and you reflect them over an imaginary line, which is perfectly diagonal, which is y equals x, okay? So let's do the inverse. So like this point here, which was 5, 0.46875, we're going to do the opposite. So we're going to, instead of 5, 0.46875, we're going to do 0.46875, 5. And that would be right there. Okay, so this point becomes that point when we invert it over y equals x. The next point, 10, 0.3.75, is going to be 3.75, 10. 15, 12.7 is going to be 12.7, 15. Okay, and then 20, 30 becomes 30, 20. Okay, and there is our inverse function. You can see that it's reflected over the green line. So this is w inverse of h, whereas our blue function is w of h. Okay, let's go back to the original problem, see what else they're going to ask us. Graph the inverse function. We did that. Find the inverse function. Okay, so find the inverse function. So basically, we're going to do that by drawing the arrow mapping technique. So we're going to start with our function wh, which is equal to 0.00375 h cubed, right? So this is basically y equals 0.00375 x cubed, right? So if we were to draw a diagram which shows this process, first we have x being cubed, then we have that being multiplied by 0.00375, and then you get y. If we want to find the inverse function, we reverse that. We have x going into dividing by 0.00375, and then we cube root instead of cube, and then we get y back. So the inverse function will be y equals x divided by 0.00375, and then we cube root the whole thing. Make sure that you cube root the whole thing and not just the numerator. You need to cube root both the denominator and the numerator. So it should extend all the way down to here. A lot of times people have trouble knowing where they should stop the root sign. Okay, find the coordinates of the point where the function and its inverse function intersect. So to find that, we could see graphically that it seems to intersect close to, 16, 16, around there. To see exactly where it intersects, we can use the calculator, and we could put in the inverse function in for y2. And remember, the inverse function was cube root is math, number 4. So cube root, and then inside here I'm going to put x divided by 0.00375. So I'm going to put x divided by 0.00375. Since there's just two numbers on top of each other, I don't really need parentheses for anything. 0.00375, not 0.375. 375. Okay, then I'm going to graph. Okay, and then I'm just going to find that intersection point. So I'll do second calc, intersect, number 5, first curve, second curve, guess. And the answer is going to be 16.3, 16.3. Okay, so that is problem 1. Problem 2, it's an optimization problem. A farmer has a rectangular enclosure with a straight hedge running down one side. So a hedge is like a bush. So I'm just going to color it green so that you can see that is. So you have a straight hedge running down one side. The area of the enclosure is 162 meters squared. He encloses this area using X meters of hedge on one side as shown. Okay. If he uses Y meters of fencing to complete the enclosure, so that would be like here, here, and here, this would be length of Y total. Show that Y equals X plus 324 divided by X. Okay, and so now we're going to follow some of these hints. Assuming that the enclosure is X by Z meters, find a constraint equation for the area using X and Z and the given information. Well, if this is X, then this must be X also, right? This must be the other dimension, Z. So if I was to find the area here, that would be the length times the width, so it would be X times Z. So X times Z equals area. And we know that the area is 162. So we can rewrite this as 162 equals X times Z. Rearrange the constraint equation for Z in terms of X, Z on the left by rearrange the constraint equation for Z in terms of X. Z on left by itself, numbers and X on the right. So can we do that with this? So let's put Z by itself, or let's put reverse this first so that we have Z and X on the left, and then we have 162 on the right. Now we want Z by itself on the left. Let's divide both sides by X in order to do that. So we'll end up with Z equals 162 divided by X. Okay? So now the next step says write an optimization equation which calculates the total amount of fence with X and Z. So total amount of fence is this blue line here. You can see that Y is equal to Z plus X, right? And we want it just in terms of X, so eliminate Z by using the constraint equation expression, which is this. So now I'm going to put 162 divided by X every time I see Z. So 162 divided by X plus 162 divided by X plus X is Y. I can simplify this because then I can add together 162 over X plus 162 over X. That's like 162 times 1 over X plus 162 times 1 over X. If you add those two together, you'll get double 162, which is 324 times 1 over X, which is equal to 324 divided by X. So now I've finally gotten the expression that they refer to right here, right? So that's the first part. Then it says the farmer wishes to use the least amount of fencing, so find the X which makes Y a minimum. So, of course, I'm going to use the calculator for that. Now that we have this expression, Y equals X plus 324 divided by X, let's graph that and see what the minimum point is, because we want to know the minimum amount of fencing possible. Okay, and if you want to, you know how I use the math function. Let's clear that. I'm going to use the math function so that I don't have to use parentheses for anything. So I'm going to do X plus, and then I can put math, number, go up, and then I'm going to put 324 on top, and then I'm going to put X on the bottom. Then I'm going to graph. Maybe I can't see it because it's too high up, so let's do a zoom fit. Zoom fit. Oh my gosh, this button doesn't work very well. Okay, zoom fit, there we go. Enter. Okay, we can't see very well there either, so we don't need quite that much zoom out. So let's do window, and then we'll reduce the amount of Y max to about, I don't know, 500. Is that too much? And then the Y min we'll put 0. Let's see. That's pretty good. Okay. So we're gonna see where the minimum value is. It's kind of hard to see on this, so let's readjust one more time the window. Instead of 500, let's put like 200. What did I do wrong? Window. Oh, I put 2. It's supposed to be 200. Wondering why nothing was happening. Graph. Okay, now I can kind of see a little bit. This looks like the minimum looks like it's around there. Let's make it a little bit wider to make sure we get the minimum. So we'll go to about 50. Alright, so let's grab the minimum there, doing second calc minimum, number 3. And I'm going to move, oops, I need to do the left bound. Let's try one more time. Second calc minimum. Okay, the left bound is over there. So let me go to the left. Enter. And then I go to the right. Go slightly to the right. Enter. And do guess. And so the minimum is 18,36. First they're asking me for the value of x, which makes y a minimum, so I can say it's 18. Calculate this minimum value of y is 36, we already know. Okay. Then it says draw an accurate graph of this function using a horizontal scale from 0 to 40 and a vertical scale up to 50. So let's adjust our window so that it looks like that. So it would be 0 to 40, and then the y min would be 0 to 50. I forgot a 0 here. 0 to 40 and 0 to 50, just like it says here. And then we're going to graph. So we're going to draw a graph that kind of looks like that on the grid. So we go down to the next grid paper. So we're going to go from 0 to 40. So this is 10, 20, 30, 40. And we're going to go up to 50. 10, 20, 30, 40, 50. Perfect. Okay. Let's do blue. And then we're going to do second table to get some of our numbers. Perfect. It counts by 5. That's fine. Oh, and look, there's a problem here. It's not in decimals because I used the math function. That's okay. You just go over here and then you put fraction. So I'll go to math. No, decimal. Decimal. Okay, now I can go to table again. And it should be in decimal. Yes, it is. So 0 is an asymptote. 0 is an asymptote. So there's nothing here. 5, 69.8, it's off the screen. 10, 42.4. So that would be, 10, 20, 30, 40. So 42.4 would be there. 15, 36.6. 36.6. 20, 36.2. 25 comma 37.96, 30 comma 40.8, let's go to the next screen, 35 comma 44, and 40 comma 48. Should be about there. So if we draw a curve through our points, it kind of looks like that. Okay. Let me just check. 50 comma 10, 20, yeah, so 40 comma 48, 35 comma 44, oh, 44 is here, 35 comma 44, it's about there. Okay, so let's get rid of that, 48, okay, so it's about like that. That makes more sense. Okay, so that's it for the graphing. So we're done with number 2 also.